Okay, so today we are going to look at the next type of method to represent electrons. Okay, so this is called electron configuration notation, and it is essentially a third method to represent the location of electrons in an atom. So this is the definition. Okay, so electron configuration notation. Okay. Essentially what you're going to do is you're going to eliminate the lines and arrows from the orbital notation that we used, and we're going to use superscripts to represent the number of electrons in a particular sublevel. And if you remember, our sublevels were the S, the P, and the D, and the F. Okay? So, I'm going to review a little bit our orbital notation. Okay, and going back to hydrogen, orbital notation for hydrogen was simply this. Okay? So that is orbital notation. If we get really big and we do something like aluminum, okay, the orbital notation for aluminum, okay, which has 13 electrons in it, we had to start at 1s, 2s, then we went to 2p, and then we went 3s, and then we went 3p. Okay, and then we put all the electrons in there. Okay, and so that is our orbital notation. And remember, the method that we fill these, that's where this particular table came in, our table of filling. Okay. This is going to be a good table to keep with you even with the next method that we're going to use. Okay? So, essentially what electron configuration does is we're going to eliminate the lines and we're going to use superscripts. So, for orbital notation for hydrogen, and we'll always start simple with hydrogen, is we essentially eliminate most of this. Okay? And what we're going to do is we're going to write 1s, and then here there's one electron in that 1s, so we're going to superscript that and write 1s1. Okay? And this right here, what we have left, this thing right here, that is our electron configuration notation. So the nice thing with electron configuration notation is if you have the orbital notation, you actually already have the electron config as well. Because if I write the electron config for aluminum, all you do is get rid of the line and arrows. You just get rid of that. So I would write 1s2 for these two electrons, and then I would write 2s2 for those two electrons, and then I would write 2p. And then in this 2p, there are 6 electrons, so we'll write 2p6. And then for 3s, there are these 2 electrons, so we'll write 3s2. And then for 3p, there's only 1 electron here, so we'll write 3p1. Okay? So this method right here then basically is our new method to write or represent electrons. And a few things to notice when we get to p orbitals, we don't care about the rooms that they're in. We just care that there's 6 of them. These p orbitals here, I only care that there's 1 electron in that room. I don't care what room it's in. So in essence, this is a little bit easier to deal with. Okay? Now, a few things when you write this. I don't know if I can move this whole thing down or not. Nope. Okay? So when you rewrite this, there's a few things that you will use to know that you wrote these correctly. These numbers here all represent the number of electrons. Okay? So, if aluminum has 13 electrons, and then 2 plus 2 plus 6 plus 2 plus 1 has to be 13. So these numbers up here on top are essentially your numbers of electrons, and they are superscripted. Okay? So, let's just start practicing with these chance to write. So, let's start practicing with this new method. Okay? So, let's write lithium. Okay? And I'm going to write the orbital notation first. So this is our old method. Okay, so this is orbital notation. Okay. So to write electron config, it's just 1s2, 2s1. Okay. Let's get into a little bit higher. Let's go to oxygen. Okay. And I'm going to do one more this way, and then I'm going to start getting rid of this. Okay. So this is the orbital. This is our orbital notation for oxygen. Okay. But electron configuration notation just gets rid of that. So 1s2, 2s2, 2p4. Okay? And again, right here, that little 4 right there only concerns itself with these 4 electrons. And again, now the nice thing is I don't care where they're at. I just care that there are 4 of them right there. I don't care that they're in the -1, 0, and 1 room anymore. Okay? We just care that there's 4 of them. Now, when writing these, okay, again, this table for order of filling helps because you still have to follow the correct order of filling. Okay, so if you have this table handy, you want to use it. Okay, but again, all of this comes off of our periodic table as well. So I'm going to write the electron configuration notation for iron. Okay, but I'm going to follow the periodic table to help me do this, because if you can follow the periodic table, you're good. Remember, we always have to go start here, so I have 1s2, and that took care of that helium as well. Then I go here, okay, well that's 2s, okay, so 2s2, okay, then I go across here, and that's 2p, okay, so I'm going to do 2p, And we're going to do all 6 of them because 1, 2, 3, 4, 5, 6. And we went through all of them, so 2p6. Then I'm going to go through these 2, which is 3s. So that's 3s2. Okay, then I'm going to go all the way across over here to 3p. So that's 3p. And again, I went through all 6 of them. So 3p6. Okay. Now, this is where it gets a little tricky. You're going to go here to 4s. So 4s2. But now, I am in 3D. But you just count over. 1, 2, 3, 4, 5, 6. So this level is 3D6. And that would be your electron configuration notation for iron. Okay? Let's pick another element. Okay? Let's go with germanium. Okay? So we're going to do germanium. Always start at the beginning. Okay? So 1s2. That takes care of those 2. 2s2. That takes care of those 2. These are 2p's. So 2p6. 3s2. Then we go all the way over here. These are 3p's. So 3p6. Then we go here. 4s2. And now we have to transition through this entire region, which we have to remember is 3D. So we're going to go all the way across 3D10. And then we're going to go over to here, which is 4p, because that's my 4p region. And I'll just go over 2, because I go 1, 2. You just count them over. And that would be your electron configuration notation for germanium. So yes, these can get pretty long, okay? But the other thing is, if you're not sure of order, this table helps you. Okay, so I just want to do one thing. Okay, if I display both of these pages at the same time, hopefully you can see this. Okay, where we filled the 1s, 2s, 2p. Then we went 3s and 3p. Then we went 4s, but then we snuck back up here and did 3d, then 4p. Okay? So we did follow the correct order by going 3D. That's where these lines come in. Okay? Okay? We're going to do another kind of big one. Okay? We're going to go down here and we're going to do palladium, PD. Okay? So, how do you get to palladium? Well, you always have to start up here, 1s2. Okay, that takes care of him as well. Then 2s2. 2p6. 3s2. Then 3p6, 4s2, and here's 3d10, and then we jump back to 4p6. Now we're at, and I'm going to go down here, 5s2. Okay, but now remember here, we're back to D's, okay, but this was 3, this was 3, this is 4, so we're dropping back down a level to 4, and they are 4 D's, and you are moving over 1, 2, 3, 4, 5, 6, 7, 8 of them, so 4D8. Okay, and then you're done. So now I no longer care that there's 4D and I don't have to worry about doing this thing anymore. Okay, I don't care where they're at, I just care that there are 8 of them. So this is no longer needed. Okay, so I'm going to have you practice, but we're going to go back to a few simple ones here. So, let's go back to fluorine, and you write the electron configuration for fluorine. So you have 1s2, 2s2, 2p5. And that's it. Okay? Let's have you do chlorine now. Chlorine is right here. We just did fluorine, which is serious. Yep, do chlorine. That's okay. Okay, 1s2, 2s2, 2p6, 3s2, 3p5. That would be it. All right, one last one, okay? And this one's going to be a big one, and you're going to do a lot of writing. I'm going to have you do osmium. Okay? Go. If you want to look up or you want to finish, okay, this one's going to be extremely long. Okay? So, again, starting, you should get really good at the first beginning ones because you will always be writing 1s2, 2s2, 2p6, but then it's just a matter of how do I get to osmium, okay? What do you have to go through? I have to go 3s2, then I have to go through 3p6, then I have to go through 4s2, then I have to go through 3d10, then I have to go through 4p6, then I have to go through 5s2, then I have to go through 4d10, okay, then I jump back up and I'm at 5p6, okay, then I'm at 6s2. Here's the one everybody forgets. From here, you have to go here. And you have to go all the way through these 4f's. So your next one is 4f14. That's the big tricky one that people miss. And once you have that one, now you're back to 5D. And in the 5Ds, you are 1, 2, 3, 4, 5, 6. So you are 5D6. So yes, this gets a little bit long. There's a shortcut. Okay, I won't show you the shortcut until tomorrow.